Well, hi, and thanks for joining me here in my shop this morning. So I kind of think I'm in the final stages here of finishing off this radio. So what that looks like is maybe a little bit of tube testing might be a smart idea. I tested these two; they're fine. Just 3 more plus this guy. Chances are they're all fine, but I think I probably will test them. It's not that much effort to do it. One of the things that makes me interested in testing them, since I tend to be driven by some kind of observation, is I was in here yesterday evening trying the shortwave. You can see the shortwave button pushed here. And what I discovered was the shortwave band works, but barely so. So a fairly strong shortwave signal, you can barely pick it up on here. I also applied my signal generator to it just to double check that, and sure enough you need a pretty strong signal to show up. So that's suggesting 2 possibilities. One is a weak tube in here, and the other possibility, probably the more likely possibility, is poor alignment in this old radio. And of course the last possibility is defective components, of which there could be many. Maybe not completely defective, but slightly defective, and I'm talking about, of course, capacitors. Okay, so I think I'm going to start with the tube testing. Why not? And I've only got 4 tubes to test, so I'm going to get busy on that. Okay, so I've got my Weston tube tester here. It's newer than my other tube testers, and so it has listings of newer tubes like this, the ECC85. This is the tube that's used in the FM front end of these radios. So don't plug it in yet. Let's set it up here. ECC85 6.3, signal set to 4, bias 21L, and 35176, 35176, PGK1, PGK1, UCC85, just double checking F, very important. So if the meter comes up to 1250, which would be roughly this part here, then the tube qualifies as good. This is a twin triode. So we do one test and then I flip these switches and do another test. We're ready to go here. Let's just turn the unit on. I like to have it on because I like to watch the pilot light while I plug the tube in and see the pilot light dip a little bit. Yeah, see it dip a little bit there? Hopefully you saw that. Okay, after a moment, do a short test. Oh, what happened there? Ooh, what's going on here? So you don't expect this to go up at all. I'm not sure what was going on there. Where did that come from? It might be my tube tester here. I think it's just a tube tester. Oh, what's going on? I've worn out the socket. Okay, no shorts. Up above 1250. Right on the 1250 mark. Other half of the same tube. Oh, it's coming out low on here. It's also not stable. So this is reading a little bit low. Now let's just check the sensitivity of things like meter adjust. It doesn't take too much to get it up, and also the bias here. So see, it's just a slight variation in the bias setting to make it big. So if I had these, if these are a couple percent this way, a couple percent that way, this could come up and look good. So the tube is functioning. I mean, I guess if we go to do the FM side and we start thinking there's something going on with weakness or whatnot, maybe this is the tube to go after. I've got a few of these in my stock, I'm pretty sure. Okay, so this would be the first tube in the IF string. This is probably the converter tube here. Let's see what it's called. What's it called? Right, I can't read that. ECH81, I think is what it says. It's very hard to read. ECH81. So the wall chart. ECH81 right there. 6AJ8. Wow, all these tubes, like 6AJ8, that when I hear that number, I think that tube is nothing. Turns out that's not true. Here we go. So 6.3, 4 on the signal, 15L, bias 00176, 00176, 0035, 003. Sensitivity is 46. D. In this case, 1180 is the reject point, so it's just above 1,000 here. And this is a one-part. This is just a simple triode. I believe that's what it's saying there. 9 pins on a simple triode. I didn't see any jump there, but I really wasn't looking too close. It's definitely heating up. Okay. So when I do the short test, I'm really looking for the meter coming up quite a distance. It almost always hops up just one division here when I'm doing the test. Oh, I should be back here. Let's repeat this. And away we go. And so it's way up there. So I don't think we can consider this tube to be any kind of problem. Just as I kind of suspected. So I'm going to put it back in here. We'll get the next one. So the next one is the IF amplifier tube. And this one is really usually in these radios, in all radios, is responsible for the gain of the radio. EF89. So we'll look for EF89, there it is. Okay. 6.3 to 34L 05176 05176 0342 0342. And you see, I'm not double checking all this because I'm concentrating very heavily here while I do it. So I don't think I'm making a mistake. D. Okay, passing is similar again, 1170, so up above the 1,000 here. This is a pentode. EF89. EF89. Okay, and it goes. So even if this tube was dead, the radio wouldn't work. If the tube was really, really weak, it wouldn't work either. So the chance of getting a bad tester is pretty low. The radio is its own tube tester. In fact, anybody who does this will tell you, if you test a tube kind of weak in a tube tester, don't throw it away, because it may work fine in the radio you're interested in. Here we go. What was that? It's going to be EF89 1170. So we're well above 1170 here. There we go. One more tube to go. And then we can really conclude that any weakness is not coming from a weak tube. This is really a process of elimination here. E, A, B, C, 80. So when it has a lot of letters, the European style has a lot of letters, it means it has a lot of functions. Can you see in there? There's 3 separate tubes inside here. 3 separate plates. E, A, B, C, E. Wow, right at the end of the roll here. Good show, just me. These roll charts tend to jam up at the end, at the ends. E, A, B, C, 80. 3 tests to do this. Test number 1, 6.3, 125. L on the bias, 00076. 00076. 0153, 0153. Actually, the reason I'm not double checking this is because I know you are. And 32 on the sensitivity. That calibrates the meter. I believe that's what this is doing here. F. Okay, rejection point this time is under 1,000. 910. This is testing the triode that's in this tube. There it goes. Yeah, I think I'm going to have to replace this socket here. That tube is just glowing to beat. Wow, that's glowing like crazy. I remember it glowing that much. 6.3, 6.3. Maybe it's because there's 3 heaters in there. You get 3 times the glow. Short circuits. You're doing the short circuit test to a large degree to protect your tube tester from a shorted tube. Up to 1,000. Oh, it goes well over 1,000. There you go. Now, what are the chances that these diodes are bad? Really low. So, 31. 3100. I'm going to turn this off while I change these settings. So 00076, 3100. In some tube testers, you can change these settings all you like while the tube's in and while the set is on, while the tester's on. In others, you can't. I can't remember this one. So I'm not taking any chances. I've taken chances before that realizing. So diode number 1. Now the diode test, it just has to come up above here where it says diodes OK. That's all it's got to do. Power on. I am double checking things a little bit here. A. Looks like there's 3 diodes in this. So we're doing diode number 1 this way. So I think the reason there's 3 diodes is because it's an FM receiver. So it uses 2 of the diodes in the detection of the FM signal. Probably. And the last diode is probably using for the detection of the AM signal. Maybe we should take a look at the schematic. We should run through the schematic quickly before I do the alignment, just in case there's something there I need to know. Okay, so short test anyway. I'm not sure I need to do it. Having done it already. Diode number 1. Diode, just up above that. No problem. Now, doing diode number 2. I'm going to turn the set off. Probably unnecessarily. P3176. P3176. 0K00. 0K00. 38. A. So now we do a set of tests with the switches here, then we throw the switches and do the second test. That'll be the third diode on. I'd just be stunned if this doesn't show good. Okay, diodes and rectifiers up above the OK line. And repeat the test. Oh! Wait. Hold on. What am I doing wrong here? P1, K1. And P2, K2. So no G. So this is the problem. I'm throwing this switch and I shouldn't. Okay, try her now. Uh-oh. Okay, wait. Bad socket. Bad socket. I gotta get rid of the socket here. I think that's all it is. Good. Look at that thing. It's glowing like a son of a gun. Getting hot too. You see some dark spots here. And behind those dark spots are holes in the plate there. So again, a black material of some sort is coming out of there, I think. I don't know. Anyway. Okay, so tube's not an issue. Yeah, okay, so tube's not an issue. So, a weak shortwave. We're left with alignment and component problems. I think it makes sense to perform the alignment at this point. Usually when I approach these kinds of things, I think to myself, I'm going to go through the alignment. The first time I go through it, I'm going to mess it up. It's just inevitable. So by the time I finish the first time through messing it up, I now know how to not mess it up and go through it and do it again. The first time through then is very much a practice, a dry run, that kind of thing. I've already looked at the instructions for this. It's not very complicated. It's not as complicated as some other radios. What's complicated in here is doing the alignment on the FM side of it. So I think maybe running through the schematic at this point would be a good idea. So why don't we do that? So I started looking at the schematic here, just getting ready to talk about it, getting it on the screen and that, and when I scrolled it down this far, I noticed this table here of resistance readings. These are great. These are made with the unit switched off, and you pull the tube out, and you just stick your probe into each of these pins and read the value compared to this table. And it's a great way to hunt down problems in a radio like this. So I'm going to go through this table. I'm going to go through all these tests and just see if I can find something anomalous before going any further with it. Okay, well, let's get started here. So we're going to start with this tube. What's that? ECC85. We'll start with this one right up here. Now if there's trouble in this in the FM part up in this box here, yikes, I'm not so sure I'm interested in taking a look at it. Let's just check the zero on the meter. I think, what have I got it set? I got it set to 200. So there's zero for sure. So it's basically from the tube pin to the chassis is what the readings are. Oh my gosh, not with this. This won't make it in there. So I'm going to pop in a tube extender here. Okay, got the 9-pin extender here. Tell me it's not going to plug in because of this. Ah. Oh, man. So the guard here is stopping this from sinking low enough to plug in. I need a little pinny thing here for crying out loud. What have I got? Not even that, son of a gun. Uh-oh. Jeepers creepers. Okay, it's not many measurements, so I'm just going to have to kind of fudge my way through this. So I'll use that just to stick in the hole here. Okay, now referring to the table, pin number 1. Pin number 1 would be this. You know what, I can't interpret these things at all. Okay, well that didn't work out. Let's hope we have better luck with the rest of the tubes here. I'm not There's something going totally wrong with my testing here. Oh, look at that. Gimmick. I've got a gimmick in here. A gimmick is just a twisted piece of wire, twisted in a very special way, sort of thing. That's what that is. It's the kind of thing a guy like me can spot and not know what it is and just go, oh, that's broken, and solder things together that shouldn't be soldered and stuff like that. So watch out for those. Oh, this is really, You know what, this is going nowhere but raising questions about a set that's working. Or is it working? That's the question. Well, the other alternative is to measure voltages on here. Forget the resistances, measure the voltages and make sure the voltages are correct. So I think I'm going to stop using that table because it's driving me nuts. I'm going to revert to measuring voltages on these tubes, starting with this one. I think that's the only sensible thing I can do here. Starting with this one here. Get them in the center. More or less. There it is. Okay. Oh my gosh. What could be going on? Maybe I'm taking those measurements to the wrong place. I looked, it doesn't seem to describe where to take the measurements to, so I just took them to the chassis here. Same thing with the voltage measurements. Talking about that. Let's put this guy on 1000 here. So I have this tube and the tube extender, which gives me easy access to all the pins, which is great. Speakers connected. We're switched on AM, so we should hear something. Okay. Let me just get my hand on the volume here. Down it goes. Ready on the power. Power on. Oh. Just sucked the life out of my meter there. Okay. Let's give it full power. Let's turn it up. What do we got? Okay, so we're definitely on medium wave. No antenna. So there's full volume. You know, that's just a little unnerving. Let's stick a little antenna on there. I don't want the volume up so high while I'm doing this kind of stuff. It didn't make much difference. Okay, in any case, we know the radio is working. So, starting on the chart, starting on the diagram rather, looking at pin number, oh my gosh, what are those numbers? I would say that's pin number 1. It should have 70 in FM, 90 in AM. We're in AM, so it should be 90. 90 on pin 1. Pin 1 is here. Voltmeter set to DC volts. Correct. There we go. Ka-chunk. So now that is supposed to be, just making sure I don't have any restrictions in here. No. 90 on AM, 70 on FM. FM looks good. AM, it's supposed to go up and it's gone down. Okay, pin number 6 should have 260 volts on it. Pin number 6. Has 254. Again, we're looking for gross errors here. And FM, it should drop a little bit. FM, drop a little bit. AM back. So we've measured the screen voltage, we've measured the plate voltage. We should measure the bias, which is a little more tricky with a meter like this. Probably can't really measure the bias. I won't even try. Oh, wait a minute. Minus 12. It's really hard to look at this chart here. I was going to point, but unfortunately my pointer goes behind the diagram. Point with this. Point with this. Okay, so that's got to be a hop right there. Pin 7. What's that say? Minus 12? Must be. Minus 6 and minus... This minus 12 though would... Well, look at me play. Okay, what is this? Mixer. Okay, hello. I'm sort of lost my head here. 2 grids in a mixer. One of them has minus 12, one has minus 7. One is pin 2 and one is pin 7. Pin 2, pin 7. Pin 2, pin 7. Pin 2. Wow, that brings this guy to life, doesn't it? Pin 2 and pin 7. It's another grid. Okay, so pin 7 should be minus 12 in AM, and we're in AM mode right now. Pin 2 should be, wow, these are tricky to read here. Minus 1.5. Pin 2. Didn't that make a lot of noise last time? Pin 2. I missed pin 2. Pin 2. Okay, no, it looks okay. Bias and plate voltage and that are okay on this too. That's how I would define that. Good enough. Regardless of all those other... all those other resistance tests. Not that hot. This guy next. Okay, we're in. Power on. EF80. You know what? I didn't do half the 81. There's another one. Oh. Well, that's a little different. What has happened? What happened? Let me tune the radio. Oh, won't tune it with that. Tune it with this. So somehow we've ended up being able to pick up a noise signal here that we didn't hear before. Kind of like that. There. We'll leave that muffled thing going there. Holy smokes, man. I feel like I'm just hanging by a thread here. Okay, and we're going back to EF80. EF80. Are you on there? EF80. Okay, must be a different EF80. Come to me. Where are you? Should be over here. Maybe it's an 89. Maybe I've read it wrong. EF80. It's EF89. That's my problem. EF89. Okay, those are the numbers. 200 on the plate, which is pin number 7. Let's go look at that. $250 on the plate, and the expectation is 200. Okay, on the screen, pin number 8 should be 30 volts. There's a problem here. 5, 6, 7 order. I'm on the wrong pin. So that's supposed to be 30 volts. It's high at 50. Okay, so we should... what? What are they doing here? It should be -1 on pin 2. Nothing showing up. Reading the wrong... no, it's not pin 2. Pin 2 should be... yeah, it is. It's pin 2. Pin 2 is nothing. Wow, what's going on? Somebody save me from myself. Well, apparently no bias at all. Pin number 9 is supposed to be -0.7. Pin number 9. -0.7. Pin number 2, -1. And where's it pulling that from? Ooh, wow, it's a lot of wire on that diagram. I'm trying to figure out where stuff comes from. Pin number 2. 1, 2. Oh, there we go. Maybe I just wasn't hitting pin number 2 before. There we are. Good. Okay, I guess I'm just not reading those numbers carefully enough. So there we go. So we've got plate, screen, it's all there. The radio's working, it has to be there. It has to be there. I can do one more. Why not? Still have anomalies on this tube. Don't we? I have to go back and test it because I only did part of that tube. Power on. I say that out loud so the co-pilot knows what I've done when I say power on. Hey, that would be you. You're the co-pilot. Okay, in this case, this is now the something or other 80. It's the EABC 80, another multi-part tube. So there's a diode part, not too interested in that. EABC, this is what I want to check right here. Pin 9 should have 60 volts on it. Pin 9 has 60 volts. Pin 9. That's pretty close. And what else? Pin nothing else of any significance here. Great. Power off. Now I'm going to do a couple of really important ones. This one anyway, I don't know about getting at that one because this shield is in the way here, unless I can pull that shield off, which I don't think I can. I want to make sure the grid, the power tubes here are properly biased. That's where I'm after. I can get it to pins right on the socket, come to think of it. Come to see it. Ouch. That's a hot tube, man. Supposed to get a centimeter of rain today. It looks like we're going to get 0. I was really looking forward to some rain, oddly enough. You come out. Some of these tube sockets look greasy. Look greasy or oily or something. Power on, here we go. Okay, now this guy, this is the 6BQ5, and it's located right here. This is EL84 is a 6BQ5. This would be maximum B+, 280 on pin 7, 230 on pin 9. 280 on pin 7. Okay, full power. Geez, every time I move the power from the dim bulb setting to full setting, something inside this radio makes a noise as I flip the switch. It's really quite distracting, maybe would be the word for it. Now that I've lost track of what I was doing. 280 on 7. Keep my finger on it here. 280. I don't even take that many breaks. 280. 280 on 7. So 285 on 7, that's very good. Now, 230 on 9. A little high there. And then, so what was it on here? Good, it's got to be, I want it to be a little higher on the plate normally. And then the last one to check is the grid bias. Where is it? It's not written anywhere. 0.5 volts. 0.5 volts is the grid bias on 2. Really? 0.5 volts? That's surprising to me. Okay, so 0.5 volts on number 2. Let's get the right number 2. Minus, that's not what we want to see. Let's double check everything here. So, you know, it says 0.5 volts. Positive 0.5 volts. Well, and the other two, 2 volts on the grid, positive. The other tube, the other output tube. Oh, I don't get that. Really? Positive voltages on the grids of output tubes. Yikes. Okay, another thing we can read is the oh my gosh, these aren't done the same way. So the what's going on here? The grid bias on the EL84 is not coming from a cathode resistor, but the CL86 is coming from a cathode resistor, 150 ohms. Wow, these are totally, I'm discombobulated. Okay, wait a minute. I see what's going on. The 150 ohms is running the cathode, is a shared cathode resistor. The big honkin' bypass there, C3, 100 millifarad bypass, microfarad bypass. So we should see 10 volts on pin 7 or on pin 3. Pin 3 of the EL84 should have 10 volts on it. Pin, what? Wow, I heated this thing right. I heated the end of this right up. Wow. Pin 3. Pin 3. 1, 2, 3. Come on, 10 volts there. What am I doing wrong this time? So 1, 2, 3. There it is, 10. Good. So that shows the grid bias on the output tube is critical to be correct, and it is correct. The bypass capacitor, is it doing its job? We can't tell looking at it like this. Sure sounds okay. What have we found all the way through here? So all the way through here, the only thing really of interest that we found is something funny going on up here. So I'm going to go back and repeat those tests. Having gotten a little more experience here. Watch out, man! She's a skin burner. Whew, hot right through the thing. Whew, whew. That is one hot tube, baby. Whew. This whole thing is hot now. That's how much heat is. You know, the heat comes down through the pins. A lot of heat comes down through the pins on those hot tubes. It goes right into the tube socket and anything and everything it can find. This was the tube. Yeah, this is the one that has another piece to it. I didn't test. I didn't check. Okay, voltage is here. Are we ready? I think so. get that up on the screen though. So now we're going to try to look at this part of this tube. We're in the AM setting, yep. So we're supposed to find 90 on pin 8. Pin 8 of the plate has 90. Does it? Really? Does it really have 90? It really has 90. Or almost. The grid should have minus 12 on it. The grid is pin number 9. Pin number 9. Minus 5. Now I'm doing this with a voltmeter, so you know. It's not quite where you'd want it to be though, is it? 5 and 12. That's quite a difference. So let me pop this on and watch that meter. Sometimes you're bleeding down some of the voltage, and you can see it initially. No, I don't see anything like that. I was expecting, you know, this is a lousy meter. I was expecting it to jump up higher and then come back. So the voltages, you know, are kind of up and down all the way through here, as you would expect from resistors that have drifted a little bit, and I didn't plug one of the tubes in. That's probably not helping the deal. Don't touch that tube, Jim. Watch out, man. You'd almost think they'd put a cooling fan in here, but that was never done. That can't have made a difference here, I'm sure. So what do we got? What do we got? We got any explanation at all for things being low? Wasn't there some other readings here which were wrong? Let's continue on with that too. There's a funny sound again. So the other part of that tube, pin number 6. Okay, so I think I remember pin number 6 being okay. 6, 20. Pin number 6. So that's okay. I think these all tested okay now that I'm remembering. So that is supposed to be around confused at what I'm looking at here. Okay, so I'm on pin number 1. Doesn't appear here. Where's pin number 1 on here? Oh, there it is. Oh my god. I'm all over the map here. 65. Okay, sorry about that. So it's supposed to be 90, and it's 65. And pin. See, the cathode is grounded. Grid's supposed to be minus 1.5. That's really all there is. It's just the plate and this. Should be 90 or 70 in FM. So, interestingly enough, it goes up in FM, down in AM. You know, it's just not enough, I don't think, to really worry about. 65. Well, I think the next thing to do is I think we can make the assumption there's really nothing terribly wrong, voltage-wise, component-wise, all that kind of stuff. It's good enough. Alignment is next. The alignment, if it picks up the shortwave band, and that was the problem, if in the end, after alignment, the thing is still performing the same way, well, maybe that's it. Maybe that's what you get with this old guy here. So all in all, I think all I've done today is really prove a bunch of stuff that doesn't need to be, where no concern is needed. I think that's just about it. So tomorrow's alignment. Well, that's good in a way. I've eliminated a bunch of possible things that if I went ahead with the alignment would be stupid to go ahead. So, I think I've spent a good day here. Great. Okay, and see you tomorrow. Alignment day tomorrow.